This lesson has been developed in the framework of SCILED project.
Module 1, Footwear Performance and Comfort. Unit 4, Introduction to Hydrothermal Comfort.
Lesson 4.1 Thermal Comfort. This lesson is structured as follows.
Definition. What is thermal insulation? Role of footwear, structure, materials and components in thermal insulation. Comfort requirements addressing thermal comfort, recommended values for parameters. Innovative solutions to support thermal comfort.
Definition.
Thermal comfort, understood as a feeling of well-being and health, is a state of thermal equilibrium, where heat gain equals heat loss. On the contrary, a state of thermal stress in our feet can have important risks for our health and safety, becoming the cause of a decrease in the physical and mental performance of the individual, an increase in irritability and aggressiveness, as well as in distraction, thus increasing the risk of suffering an accident.
Thermal properties of the raw material determine the efficiency of heat and water exchange between the user and the environment, being important to consider them when selecting the materials for different footwear applications, thus preventing people from suffering from heat stress or cold stress in different environmental conditions. Depending on the external conditions, there might be heat transfer from hot external environments towards the foot, heat loss from the foot towards colder external environments, as well as water/vapor transfer from wet external environment towards the foot and moisture transfer from perspiration from the foot surface towards the microclimate of the footwear and then towards the external environment, if the characteristics of the footwear structure allow so.
What is thermal insulation?
Hands and feet have a large surface relative to their volume, and due to the unfavorable proportion between surface and mass of human limbs, these parts suffer from high heat losses. Feet are essential in the general thermal regulation of the body, the characteristics of the footwear being decisive in thermal comfort. Therefore, when making a design, it is necessary to think about the final use of the shoe and to take into account certain parameters. The insulation properties of shoes and boots are directly proportional to the amount of air trapped inside the fabric and between the foot and the shoe, indicating that the convection has a negative effect on the thermal insulation of the boots.
Feet feel comfortable when the temperature is about 30 and more or less 3 oC and the relative humidity close to the skin is about 60 to 65%. They begin to feel cold when the temperature of fingers is below 25 degrees Celsius, while at temperatures below 20 to 21 degrees Celsius, the discomfort of cold is noticed. A decrease in foot temperature to 20 degrees Celsius is associated with a strong perception of cold.
Role of footwear in thermal insulation.
Thermal conductivity of sheet materials used in footwear is measured by the classic Lee's disk. In this method, a constant heat source is sandwiched between two identical metal cylinders which are mounted with their axes vertical. A test specimen is placed on the top surface of the upper cylinder and a third identical metal cylinder is placed on top of the test specimen so that all cylinders in the test specimen are concentrically aligned. The thermal conductivity of the test specimen is then determined from the steady-state temperature of the three blocks, the exposed surface areas of the blocks in test specimen and the thickness of the test specimen. The table shows the recommended thermal insulation values for uppers, lining and in socks for cold weather shoes.
These values can be found in the technical reports ISO TR 20879 and ISO TR 20882.
European standards for the determination of the resistance of fabrics, fabric assemblies or fiber aggregates.
ISO 5085 to 1 textiles. Low thermal resistance, up to about 0.2 square meters kilowatt. High thermal resistance, values greater than about 0.2 square meters kilowatt up to about 0.4 square meters kilowatt.
Investigating the performance of whole footwear is far more than summing up the performance of individual parts. This is due to the combined effects of assemblies of different parts, the joining options used, the characteristics of folds and seams and other parameters. Test methods are available to evaluate the insulation of footwear against cold. In this test, the footwear is placed on a copper plate inside a cold chamber at a very low temperature, for example at -17 degrees Celsius for 30 minutes, and a temperature sensor is placed inside the footwear to record the temperature drop. The temperature decrease on the surface of the insole should not exceed 10 degrees Celsius. Test methods are available to evaluate the insulation of footwear against cold. In this test, the footwear is placed on a copper plate inside a cold chamber at a very low temperature, for example at -17 degrees Celsius for 30 minutes, and a temperature sensor is placed inside the footwear to record the temperature drop. The temperature decrease on the surface of the insole should not exceed 10 degrees Celsius. In this test, the footwear is placed on a hot plate at a very high temperature, for example 150 degrees Celsius for 30 minutes. The temperature sensor inside the shoe on the insole records the temperature increase. The increase in temperature on the surface of the insole after 30 minutes should not exceed 22 degrees Celsius.
This method is described in ISO 20344 and ISO 20877. Comfort requirements addressing thermal comfort.
The factors that affect thermal comfort in footwear are
the materials used for footwear and their properties such as thermal insulation, water vapor permeability and water absorption and desorption capacity.
The footwear models and constructions. The joining options used, the assemblies of different parts and the ventilation will influence the temperature and wet sensation of the feet.
The environmental conditions. A shoe for Nordic or Mediterranean countries has different requirements and needs in terms of materials and constructions.
The characteristics of subjects and physical activity. The heat and sweat release vary from subject to subject.
Innovative solutions to support thermal comfort.
There is no systematic analysis of personal well-being in comfortable or non-comfortable conditions related to the use of shoes. Therefore, there is a need to develop a new and more precise methodology in the comprehensive evaluation of the thermal properties of the shoe material. The methodology must take into account two integral components of the evaluation process, namely, a subjective component that reflects the opinion of the experts, and an objective component, which is based on the existing standard methods of research.